Alaska is unlike any other state in America. But what if I told you that Alaska isn't really part of North America? At least, not originally. The ground beneath Alaska is actually made up of dozens of pieces that traveled thousands of miles across the Pacific Ocean before crashing into the continent. It's like a massive geological jigsaw puzzle that's been assembling itself for the past 200 million years. So here are the most mind-blowing facts about how Alaska was built, piece by piece, through one of the most dramatic tectonic stories on Earth. To begin our story, we first need to understand what a terrane really is. Much of Alaska, as we see it today, is built from what geologists call accreted terranes. Accreted terranes are vast blocks of Earth's crust, remnants of island arcs, seamounts, and oceanic plateaus that once drifted across ancient oceans. Carried by tectonic plates, these fragments journeyed toward the edge of a continent, where they eventually collided and became permanently welded to it. The process is known as accretion. What makes terranes so fascinating is that each one has its own unique geological history, completely different from the continent it joins. Their boundaries, often marked by deep fault zones, reveal the scars of those ancient collisions. In a sense, these terranes are geological immigrants, pieces of faraway worlds that have traveled immense distances to become part of North America. Over millions of years, they've built up much of Alaska's rugged landscape, creating one of the most complex geological mosaics on Earth. The vast expanse of Alaska we know today wasn't always part of North America. In fact, most of it was added in what geologists consider relatively recent times, within the last 200 million years. That may sound ancient, but in Earth's 4.6 billion-year history, it's practically yesterday. Before these terranes arrived, the western edge of North America lay near what we now call the Rocky Mountains. Everything beyond that, stretching all the way to the Pacific, simply didn't exist as part of the continent. Over countless millions of years, those wandering fragments of crust drifted across the ocean and collided with the continent, one after another, slowly assembling the Alaska we see today. But Alaska isn't just a few terranes, it's dozens of them. Much of the state is a sprawling collage of tectonostratigraphic terranes, each displaced to varying degrees relative to one another and to the North American craton, the stable, ancient heart of the continent. Imagine trying to piece together a jigsaw puzzle where the pieces are constantly moving, rotating, and even colliding. That's essentially how Alaska formed. Some terranes have traveled hundreds, even thousands of miles from where they originated. Over time, they've been twisted, shattered by massive faults, and stacked atop one another in ways so complex they still challenge geologists today. The result is a land unlike any other, a dynamic geologic patchwork that tells the story of Earth's restless crust, written across the mountains, valleys, and coastlines of Alaska. What makes this story even more intricate is that these terranes didn't all arrive at once. They came in waves over tens of millions of years, each collision adding a new piece to the puzzle. Some terranes even merged with each other while still out in the Pacific Ocean, forming larger composite terranes before finally striking the continent. Others arrived separately, only to be torn apart by later faulting or squeezed together by new collisions. It's an incredibly dynamic process, one that hasn't stopped. Even today, Alaska continues to shift and evolve as the Pacific Plate presses northward, carrying new fragments toward the continent's edge and continuing a story that began hundreds of millions of years ago. And here's where it gets really interesting. Alaska didn't just grow randomly, it followed a pattern. Over the past 200 million years, southern Alaska expanded, as terranes were added progressively from north to south. Picture this. These fragments didn't crash in from all directions. They followed an arching pathway that roughly parallels the Gulf of Alaska. The terranes are generally older in Alaska's interior and become progressively younger toward the coast. That means if you were to drive from Fairbanks down to the Gulf of Alaska, you'd quite literally be traveling backward through time, moving from the oldest terrain collisions to the youngest. The northernmost terranes collided first, back in the Jurassic and early Cretaceous periods. Then, over millions of years, new terranes continued to arrive from the south, stacking onto the growing landmass like falling dominoes. It's a slow-motion chain reaction that took 200 million years to play out, and it's still not over. Now let's talk about Alaska's superstar terrain, Wrangellia. The Peninsula and Wrangellia terranes are parts of a dominantly oceanic super-terrain, essentially a megaterrain made up of multiple smaller ones that merged together while still out in the Pacific Ocean. By the late Triassic, about 200 million years ago, this super-terrain had already amalgamated into one massive block of crust. From there, it began its long journey across the ocean, carried by the relentless movement of tectonic plates. Eventually, during the mid to late Cretaceous, roughly 100 to 80 million years ago, it collided with and was accreted to the continental affinity terranes north of the Denali fault system. This monumental collision didn't just reshape the land, it helped define much of southern Alaska's geology as we know it today. Wrangellia's ancient volcanic rocks and oceanic origins stand as a record of that incredible voyage, a reminder of just how far pieces of the Earth can travel, and how they can change a continent forever. What makes Wrangellia so remarkable is its sheer size and composition. This wasn't just a small island chain. It was a colossal volcanic platform that formed far out in the Pacific. The rocks of Wrangellia include thick sequences of basalt, including the famous Nikolai Greenstone, which records one of the largest volcanic eruptions in Earth's history. When you stand among the Wrangell Mountains today, surrounded by these ancient greenstones, you're quite literally standing on the remains of a massive oceanic island arc, a fragment of crust that formed thousands of miles from where it sits now. It's a breathtaking reminder of the planet's restless nature and of how pieces of distant worlds can collide, merge, and ultimately build a place as extraordinary as Alaska. The Denali Fault System. It's one of Alaska's defining geological features. Stretching for more than 1,200 miles, it rivals California's San Andreas Fault in both length and significance. This massive strike-slip fault slices across the state, marking a profound boundary in Alaska's deep-time story. To the north of the Denali Fault lies crust that's distinctly continental, rocks that share a long and ancient history with the core of North America itself. But to the south, the story changes completely. Here we find Wrangellia and its companion terranes. Built from oceanic crust, volcanic arcs, and seamounts that formed thousands of miles away in the vast Pacific. When these two very different worlds collided, continental crust meeting oceanic terrain, the result was nothing short of spectacular. The immense forces of that collision crumpled and uplifted the land, giving rise to some of Alaska's most rugged and dramatic mountain ranges. Deep within the Earth, heat and pressure transformed ordinary rocks into metamorphic ones, while molten magma intruded upward, cooling into vast bodies of granite that now anchor the landscape. The Denali Fault isn't just a line on a map. It's a scar that tells the story of Alaska's birth through collision, transformation, and relentless motion. So, let's get this straight. The rocks that now make up part of southern Alaska actually began their journey hundreds of miles to the south. The sediments that formed them were eroded from rising mountains in what's now British Columbia and Washington, then carried offshore and eventually transformed into rock deep beneath the Pacific. But the story doesn't end there. Those rocks didn't stay put, they moved. During the Eocene epoch, around 50 million years ago, the entire Chugach Prince William Terrane began to drift northward along the continental margin. Geologists call this process translation. Sideways movement along massive faults. Picture a car sliding sideways on ice, only instead of a car, it's an entire block of Earth's crust. And instead of seconds, the motion unfolds over tens of millions of years. Carried along this tectonic conveyor belt, the Chugach Prince William Terrane slowly made its way north, finally docking with Alaska, adding yet another chapter to the incredible story of how this state was built, piece by piece, from fragments of faraway worlds. And then there's Southwestern Alaska, an entirely different kind of puzzle. Here, the landscape is a complex mosaic of magmatic arcs, accretionary complexes, and wandering continental fragments, all stitched together through millions of years of tectonic chaos. Magmatic arcs are chains of volcanoes that form above subduction zones, places where one tectonic plate dives beneath another. You can see a modern example of this process today in the Aleutian Islands, where fiery volcanoes trace the boundary between the Pacific Plate and Alaska. Accretionary complexes, on the other hand, are colossal scrap piles of rock, sediments, and bits of oceanic crust that were scraped off a subducting plate and plastered onto the continent's edge. And then there are the continental fragments, wayward pieces of ancient land masses that broke off long ago and traveled across the ocean on tectonic rafts before colliding and becoming part of Alaska's growing geological quilt. Together, these elements make southwestern Alaska one of the most geologically tangled regions on Earth, a place where the story of subduction, collision, and creation is written directly into the rocks beneath your feet. What makes southwestern Alaska especially challenging for geologists is that the boundaries between these different pieces, the magmatic arcs, the accretionary complexes, and the continental fragments, are often hidden from view. Over time, younger sedimentary layers from the Cretaceous period blanketed the entire region, burying much of the evidence beneath thick successions of basin deposits. In other words, nature painted over the earlier chapters of Alaska's story. It's like trying to read a book where someone spilled paint across the pages. The words are still there, but you have to work to uncover them. To peel back those layers of mystery, geologists turn to some of their most powerful tools: geochemical analysis and geochronology. By studying the chemical fingerprints of rocks and dating individual mineral grains, sometimes no bigger than a grain of sand, they can trace each fragment back to its source. Piece by piece, they're reconstructing a story that's been hidden for over 100 million years, revealing how the wild and rugged landscape of southwestern Alaska came to be. Now here's something that truly sets Alaska apart: the timescale of its creation. While most of North America had already settled into its familiar shape billions of years ago, Alaska was still very much under construction, a continent in the making. Its story stretches into surprisingly recent times, geologically speaking. When the dinosaurs vanished 66 million years ago, vast parts of what is now Alaska were still adrift in the Pacific Ocean. When the first primates appeared around 55 million years ago, new terranes were still colliding with the continent. And by the time the first horses and whales roamed the Earth, roughly 50 million years ago, the Chugach Prince William Terrane was sliding into place along Alaska's southern edge. This means Alaska's assembly overlapped with the evolution of modern life, with the rise of mammals, the cooling of Earth's climate, and the continents shifting toward their present-day positions. So while the rest of North America was an ancient, stable landmass, Alaska was still being forged, its mountains rising, its crust colliding, and its identity taking shape. In geological terms, Alaska isn't just young. It's practically a newborn, still growing and reshaping even today. The process of building Alaska wasn't peaceful, it was violent. Each time a new terrain slammed into the continent, the collision unleashed unimaginable geological forces. Mountains buckled skyward, vast regions of crust were crumpled, buried, and reborn under intense heat and pressure. Ordinary sedimentary rocks were transformed into gleaming bands of schist and gneiss, the fingerprints of metamorphism written deep within the earth. Meanwhile, far below the surface, the subducting oceanic crust began to melt. That melting generated immense volumes of magma, which slowly rose through the crust and cooled to form granite batholiths, colossal underground bodies of rock that would one day be revealed at the surface. These granites now form the solid heart of Alaska's coastal mountains, the frozen remnants of ancient magmatic fires that once blazed beneath a world in collision. Each terrain that arrived didn't just add land, it reshaped the very bones of the continent. These collisions didn't just build mountains, they shook the very foundations of the continent. Each impact between terrains unleashed colossal earthquakes, far more powerful than the magnitude 7s and 8s we experience today. Some of these ancient quakes may have reached magnitude 9 or even higher, true megaquakes capable of reshaping entire regions in a single cataclysmic moment. Thrust faults shoved older rocks up and over younger ones, stacking the crust like a geological layer cake. Strike-slip faults sliced across the landscape, shearing terrains apart and shuffling them like cards in a never-ending tectonic game. The land was constantly in motion, rising, eroding, and being buried again, a restless cycle of destruction and creation. But here's the part that's truly astonishing. Alaska's tectonic story isn't over. Even now, as you watch this, a new collision is unfolding. The Yakutat Block, a fragment of oceanic crust and sediment, is ramming into southern Alaska at roughly 2 inches per year. That may sound slow, but in geologic terms, it's lightning fast. This ongoing collision is forcing the Saint Elias Mountains skyward, home to giants like Mount Logan in Canada and Mount Saint Elias on the Alaska-Canada border, both rising higher every year. And it's not a quiet process. The same collision produced the 1964 Good Friday earthquake, a staggering magnitude 9.2 event, the second most powerful earthquake ever recorded on Earth. So while Alaska's landscape may seem timeless and still, beneath the surface, the continent is very much alive, still growing, still colliding, and still writing its story in rock and motion. The same subduction zone driving Alaska's collisions is also fueling one of the most powerful volcanic chains on Earth, the Aleutian Arc. Stretching like a fiery crescent across the North Pacific, it's a chain of volcanoes born from the relentless descent of the Pacific Plate beneath Alaska. Volcanoes like Mount Redoubt, Mount Spur, and Augustine regularly remind us that Alaska is far from dormant. Their eruptions send towering plumes of ash into the sky, sometimes high enough to disrupt air traffic across the Pacific. Deep below these peaks, magma continues to rise and crystallize, forming new granite that will one day be exposed by erosion, adding another layer, another chapter, to Alaska's ever-evolving story. But this isn't just ancient history playing out quietly underground. Alaska's tectonic activity has real consequences for the people who live there. The state experiences more earthquakes than the rest of the United States combined, over 20,000 every year. Most are too small to notice, but the big ones, they're a different story. To live in Alaska is to live with the Earth in motion. Engineers design buildings and infrastructure to bend and sway with the ground. In Anchorage, entire structures rest on steel springs and rubber pads, allowing them to flex during major quakes. Bridges and pipelines are built to cross active faults that can shift by 20 feet or more in a single event. In Alaska, the forces that built the land are still at work, shaping the mountains, fueling the volcanoes, and reminding everyone who lives there that this is a place where the Earth is very much alive. For Alaska's coastal communities, the story of tectonics isn't just written in the rocks, it's a living reality. These towns face the dual threat of powerful earthquakes and devastating tsunamis. When the great 1964 earthquake struck, the magnitude 9.2 Good Friday quake, the ground itself rose and fell like a wave. In some places, the seafloor dropped by as much as 8 feet. In others, it heaved upward by nearly 40. The quake unleashed tsunamis that wiped out coastal towns and sent waves racing across the Pacific, reaching as far as Hawaii and California. Entire forests along the coast were drowned as the land sank and salt water flooded in. Their dead trunks still stand today, gray skeletal reminders of that day when the earth convulsed. These ghost forests are silent witnesses to Alaska's restless power. So what does all of this tell us about Alaska? It reveals that this land is unlike any other in the United States. Alaska isn't a single ancient piece of North America. It's a collection of foreign worlds that collided and fused with the continent over the past 200 million years. The rocks beneath your feet in Anchorage once formed in a tropical ocean, thousands of miles to the south. The towering peaks of Denali were born from Terranes, crashing in from the Pacific. And along the coast, the land is still changing, still rising, still reshaping itself as new terrains continue to arrive. Alaska is not finished. It's a living, growing frontier, a place where the forces that shaped our planet are still on full display, carving the landscape and writing Earth's story in real time. This incredible tectonic complexity is what makes Alaska one of the most geologically diverse places on Earth. Nowhere else can you find such a breathtaking mix of time, motion, and contrast. Here, ancient Precambrian rocks, more than 1 billion years old, sit side by side with young volcanic flows that erupted only yesterday in geologic terms. In the mountains draped with ice and snow, you can find tropical coral fossils, silent evidence that these rocks once formed in warm, shallow seas thousands of miles to the south. In some places, oceanic basalt has been thrust up and over continental granite, flipping the natural order of the Earth's crust upside down. Every rock, every outcrop is a fragment of a grand tectonic journey, a record of travel, collision, and transformation. Alaska is, quite literally, a geological museum, an open-air exhibit where you can see plate tectonics in action. Its landscapes are the product of motion, collision, and creation on a continental scale, a living testament to the restless, ever-changing nature of our planet. As someone endlessly fascinated by geology, I can tell you, Alaska is one of the most extraordinary places on Earth. From a tectonic perspective, it's a living laboratory, a place where you can see the planet's engine at work. Here, we can study how continents grow, how mountains rise, and how the relentless motion of tectonic plates sculpts the face of the Earth. The same forces that built Alaska over the past 200 million years also built the towering ranges of the western United States, the rugged coast of British Columbia, and even the Andes of South America. To understand Alaska is to glimpse the very process that shapes our world. The slow, powerful choreography of plate tectonics that continues beneath our feet every day. I hope you've enjoyed this journey through time, through collisions, volcanoes, and mountain-building events to discover how Alaska was built piece by piece from fragments of faraway worlds. It's one of the most incredible tectonic stories on Earth, and it's still being written.